to add vectors algebraically, you just add the components. Add the corresponding components. I'll make up a problem for this. So vector V in position form, let's say it is 1, 3. And I'm going to go with 2 space. And vector W, we'll throw in a negative number. -2, -2. So I have these 2 vectors. I'm going to sketch them, but in fact, let's just go with V plus W would be, add the components, 1 plus -2, and then 3 plus -2. So V plus W would be -1, 1. And you can maybe look at that. Yes. That's when I had a point P and a point Q, and I was looking for vector PQ in position form. I did subtract. And if you're doing that, you subtract. If this is just adding 2 vectors. These are not points. These are vectors. So if I draw this out, vector V, initial point is at the origin. The terminal point is at 1, 3. Here's vector V. Vector W was -2, -2 for the terminal point. Here's the 2 vectors, V plus W. And what I found by adding the components, I found that the sum V plus W is -1, 1. Now, you could check the triangle rule, the parallelogram rule. Does that fit? Here's my parallelogram. Okay, those are kind of, that's quite a skewed parallelogram, but if you add the components, it matches the geometric interpretation. All right, for subtracting vectors, we'll do geometrically. Subtracting vectors geometrically. So, actually, I'm going to jog your memory a little bit. I probably don't need to jog your memory on this. You're well aware of this. So, recall that if I'm doing regular subtraction, I could do 2 minus 5. I could write that as 2 plus -5, right? If I have -3 minus -4, that's -3 plus 4. We do the same thing for vector subtraction. So, I'll write that. We do the same for vector subtraction. So I would say if I have V minus W, vector V minus vector W, I can write that as V plus negative vector W. So what is negative vector W? What is negative vector W in relation to W? There you go. I like the way you said that. The tip and the tail trade places. And so it changes direction. And so if I have W looks like this, then negative W is going to be parallel to W, and it'll go in the other direction. Still the same length as W, just the other direction. So if I have two vectors, if we have vector V, I have it going down this time, and then I have vector, here's my W right here. I'll try to use the same, pretend that's perfect. Okay. So here's V and W, and V minus W will be V plus negative W so I'll just take W, I'm gonna draw it here. So it'll go the other direction, same length, here's my negative W, and it looks like I'm using the parallelogram rule, so I'll sketch in the parallelogram. And then V minus W will be